Hey everybody, Mr. Armkey back with you for Net 125. Today we're going to get into a quick one with Module 9. We're going to look at address resolution. So our topics are going to be MAC and IP, ARP, and neighbor discovery. So we're going to talk about the roles of the MAC and IP addresses, the purpose of ARP, and how IPv6 neighbor discovery operates. So let's look at MAC and IP first. There are two primary addresses that are assigned to a device on an Ethernet LAN. So we have our physical address, which is at layer 2, and our logical address at layer 3. So the MAC address and IP address. The MAC is used for NIC to NIC, what we would call link local communications on the same Ethernet network. And the logical address is used to send packet from the source device to the destination device. We have to be able to uniquely identify each device on the network by its IP address. So layer 2 device addresses are used to deliver frames. If a destination IP is on the same network, the destination MAC is that of the destination device rather than the default gateway. On a remote network, as I said, the default gateway is your target, and then we use ARP to associate the IPv4 address with the MAC of the device NIC. ICMPv6 does the same thing with IPv6. Now let's step into talking about ARP. ARP, or Address Resolution Protocol, is used to determine the destination MAC address of a local device when it knows its IPv4 address. There's two functions here. IPv4 is resolved to MAC, and we can maintain a table of these mappings. So let's take a look at the graphic on the right. So /24 is our subnet mask. Host 5 is saying I need to send information to 192.168.1.7, but I only have the IP address. I don't know the MAC address of the device that has IP number 7. So we've got 5, 6, 7, and 8. But that's because we can kind of see a top-down view. We see it from the point of view of the switch. So how do we communicate that? We're going to send a frame by searching the ARP table for a destination IPv4 address and MAC that corresponds. If we have the IPv4 on the same network, the device is going to search the ARP table for that destination IP. If the IP address is on a different network, then we're going to search the ARP table for the default gateway. If the device locates the IPv4 address, the MAC address is used as the destination MAC address in the frame, and it's forwarded. If no ARP table entry is found, then the device is going to send an ARP request. And this is how ARP tables populate themselves. Entries in the ARP table are not permanent, however. So there's usually a timer, about 5 minutes, where the cache timer will expire and the entry will be removed. Now, as I said, it's about 5 minutes, but it will differ depending on the operating system. ARP table entries can also be removed manually by the administrator. So here we have a couple of updates you can see. They are showing the router 1 at the bottom is actually G000 to reflect the serial interface. And then we can see here that the ARP entry, they say, will be used in 2 minutes, taken out in 2 minutes. But 15 to 45 seconds can be the case in certain instances. And it's just going to depend. The ARP cache is going to be dependent on how often traffic goes through. For high traffic areas, a faster revolving ARP cache may be better. For other entries, it may be more prudent to leave it towards the default. The show IP ARP command displays the ARP table on a Cisco router. ARP-A does the same thing on a Windows 10 PC. So as we see here on the right-hand side, we've got two graphics. The upper one shows the Cisco interface, and the bottom one shows Windows. And it shows us largely the same information. It just looks at it in terms of how the table is formatted. So in the case of Cisco, we see the protocol being used, we see the address, we have an age marker which has not been filled in. We have a hardware address which basically just gives us the condensed MAC. And then we have our ARPANET type traffic, and then our interface being used, in this case, gigabit 000. If we do it on Windows, we see that the interface is given in its dotted decimal form, and then we see our internet addresses being listed as well as the physical address. So we see the mapping the same way. It's formatted a little bit differently. ARP requests are received and processed by every device on the network. Now, excessive broadcasts can cause reduction in performance. As we know, any kind of broadcast flood does do a little bit of damage to the efficiency of the whole network. We can also possibly have an intrusion. ARP replies can be spoofed by a threat actor to perform what's called an ARP poisoning attack. essentially pretending to be an ARP reply to retrieve information being sent to the default gateway. The really tricky aspect of this is that the intruder will also send a fake retrieval signal going back to the default gateway to pass traffic back to the original host. So it acts as what we call a man-in-the-middle attack. Enterprise level switches do have mitigation techniques to protect against ARP attacks. There are some verification steps that it can use. All right, let's transition into section 3, talking about neighbor discovery. So neighbor discovery, often abbreviated as ND, provides 3 things: address resolution, router discovery, and redirection services. The neighbor discovery process actually gives us a couple of different message types to carry out the items we were just discussing. So neighbor solicitation and neighbor advertisement, also called NS or NA messages, are used for device-to-device messaging for address resolution. We also have router solicitation and router advertisement messages that are used for messaging between devices and routers for router discovery. So now we've got hosts and routers. And then we have what are called redirect messages, which are used by routers for better next hop selection. Remember, the number of hops is fixed on a particular frame, so if it goes too far, the frame will die. So we want to prevent that loss as much as is possible. So we want to keep feeding new efficiency information into our routers. So here we see the neighbor discovery process to resolve the MAC address of a known IPv6 address. So here we have our neighbor solicitation message in the graphic. Hey, whoever's got 2001 DB8 ACAD1 :11, send me your MAC. And the response will come back, hi, that's me, and my MAC address is F894C2E4C50A. These are special retrieval messages using IPv6 multicast addresses. It will also incorporate Ethernet to a degree. While this chapter didn't have a huge breadth of topics, we do have some new terms that I wanted to make sure we introduced. So we've got our router solicitation and advertisement, as well as neighbor solicitation and advertisement messages, redirects, and then of course discussing ARP and the ARP table. And that's it for Chapter 9. Thanks so much for your time and attention, guys. Appreciate it as always. If you have any questions or concerns, you can always email me at jearmke063@cfcc.edu or my Google Voice number 239-7814. Hope you have a great rest of your day, and I'll catch you next class.